Remember that this video should only be used if you have exhausted all other resources. Task 5, Question 2. This time, the golfer hits the ball with an initial velocity of 72 feet per second at an angle of 84 degrees. Go ahead and mark the important information from that sentence. I'm going to mark that the initial velocity was 72 feet per second and that the angle of the hit was 84 degrees. If we continue reading, what is the maximum height above the hole that the ball reaches, and how long does it take to get to that point? Now, I want to mention that there are a lot of different ways you could solve this problem. I'm simply going to show you one approach to solve this problem. What I'm going to do is I'm going to write down the vertical component of the parametric equation, our y of t equation. So we'll know we have y of t equals negative 16t squared from our vertical motion model, plus the vertical component of the initial velocity, which should be 72 times the sine of the angle, so sine of 84 degrees, times time, plus our initial height of 12 feet that we've been using throughout this set of problems. Now, if you don't understand where that equation came from, you should watch the previous video on coming up with the model for projectile motion using parametric equations. So this is simply the y part of the parametric equations that models the path of the ball. Now, if you think about what this is modeling, it is modeling the height of the golf ball with respect to time in seconds. Now, I'm going to use my graphing calculator. I'm going to graph this equation. I'm going to graph it as a function in y and x because that's what my calculator can handle. Go ahead and turn your calculator on, go to the y equals screen, and then type in the equation negative 16x squared plus 72 sine of 84 times x plus 12. Now keep in mind our y values will now model the height, and x will actually be modeling time. Now what we want to do is we want to graph this. We should know that it's going to give us a parabola, and we can then calculate that maximum value, because that will correspond to the maximum height and the time that it takes to get there. So we need to make sure we have a good window to see all of this function. So go to your window options. Now we want to set the x min and x max to reasonable values. I've chosen 0 as an x min because I'm remembering that our x values are actually referring to times. So a time of 0 seems like a good starting point. And given the context of the problem, I know the ball is not going to be in the air for that long, so 5 seems like a reasonable number of seconds for the ball to be in the air. Maybe it'll work, maybe it won't, but it'll be a good starting point. Once you've chosen smart x values, we can let our calculator do the hard work for us. At this stage, we want to choose the zoom option and choose option 0, which would do a zoom fit. After doing so, you should end up with a graph that looks something like this. Next, we want to calculate the maximum value. So to do so, hit second, and then the trace button gives us the calculate feature, and we can choose option 4 to calculate a maximum. Upon doing so, your calculator will ask you to set a left boundary point. What I like to do when it does this is use smart values. I know that the x value of 0 is to the left, so I will hit 0 and enter, and then it will ask you to enter a right boundary point. And I know that I chose the x value of 5 to be my right point. So I can type 5 and hit enter again. Your calculator then asks you to guess where the maximum value is. It wants you to put the cursor close to the maximum that you want in case there are 2 possible answers. But since we only have one maximum value, an absolute maximum value, between the bounds that we've chosen, all we have to do is hit enter a third time, and your calculator will jump you straight to the vertex of that parabola. Furthermore, it will tell you the coordinates, which are x equals roughly 2.238 and y equals roughly 92.115. So the last thing we need to do to answer this question is interpret our results. What this means is that the object will reach a maximum height of 92.115 feet after a time of 2.238 seconds. We have to remember that x is really referring to our time in seconds. And again, this is merely one approach to the problem. There are many different ways you could solve this problem.